Section 2.4, Day 2, Modeling Real-World Data Using Technology. So today what we're going to do is we're going to use our calculator to help us make scatter plots to find the trend line. So you're asking yourself, what's a scatter plot? A scatter plot is a graph that relates two different sets of data by plotting the data as ordered pairs. You can use the scatter plot to determine a relationship between the data sets. So let's look at these graphs that we have right below the scatter plot definition. So below it we have our first graph. You notice that the scatter plot dots are going in a positive direction. So we call this a weak positive correlation because the points are kind of scattered a little bit far away, but not quite close enough together. So this second graph that we have here, our points, notice, are going in a positive direction and they're a little bit closer together, so we call this a strong positive correlation. For the third graph that we have, these dots are going in the negative direction and they're not quite as close together, so we call this a weak negative correlation. The fourth graph that we have here, the points are going in a negative direction and also they're a little bit closer together, so we call that a strong negative correlation. And for the graph number 5, if you look here, these graphs are kind of scattered everywhere that we have. So this we would say is no correlation. So a trend line is a line that approximates the relationship between the data sets of a scatter plot. You can use the trend line to make predictions. Trend lines, if you remember, are also called linear models. We also call them linear regression. We also call it a prediction line. So there's many different names that we can call this, or sometimes they'll just say find a model that fits the data set that you have. So it's cool because our calculator is able to calculate the line that is the best fit for the given data sets that you have. And so what the calculator does, if we look at this first graph that we have, it would try to pick a line that would go somewhere between the points that hits as many points as we can and has as many above the line as it does below. So that would be a good trend line if my calculator to graph it. However, this next line that I'm going to draw, if I were to make one like over here, notice that that's way above all my data points. So that would not be a good trend line to use because it doesn't really hit a lot of our data points. So I'm going to erase that. So then, how does your calculator do this? Your calculator uses what's called the correlation coefficient, so you should write this down. And this correlation coefficient, when we see when we're graphing these, is actually this R value that you will see that comes up on your graph. And the correlation coefficient determines how well that the data fits the line that you're given, that your calculator is predicting. So the closer the R value is to 1 or -1, the better fit the line is for the given data. So it determines how fit the line is. And why do we use 1 or -1? Because if it's a positive slope, and if every single point were to be on the predicted line that you got, so let's say you had a graph and every point was in a nice straight line like this, and your line then when you graphed it hit every single point on that line and went through, that would be a correlation, our R value of 1. If my line was going in the negative direction and it hit every single data point with our predicted line, then it would be -1. So we're going to be doing this in our graphing calculator. So it says, example, graph each set of data. We want to decide whether a linear model is reasonable. If so, draw the trend line and write an equation. And underneath the table, it says, let's plot the data. Graph the data as ordered pairs with 1990 corresponding to x equals 0. And so when we do this, 1990 would be 0, 1992 would be 2, 3, 6, 8, and 10. In our graphing calculator, we're going to graph L1 as the x values. And L2, list 2, is going to be our y values. And we're going to use our graphing calculator to do this to make the scatter plot, because otherwise if we did this by hand it would take us a lot longer. So now if you go to your calculator, and I suggest that you do this problem as I'm doing it. So in my calculator I'm going to go to make a scatter plot. So I need to go to Stat, and on the first one you're going to hit Enter. Now, if you have something in your list, you're going to want to clear out. The way that I do that is I'll hit my up arrow till it highlights the list and hit clear, and then push down. And then I'm going to do the same thing on the other side. Highlight L1, hit clear, push down. So when you do this, I recommend that you never hit delete, because then it would accidentally delete your list out of the entire column, and then I would have to put it back in for you. So we're going to enter the data that we had from our list. So we had 1990 was 0, and then enter. Then 2, enter. 3, enter. 6, 8, and 10. Now those were the x values. Now I'm going to go into list 2 and put the y values. So 122.9, enter. 121.5, 130, 140, 152.2, and 169. Enter. So I always check to make sure my list have the same amount of numbers in them, and so in case that I might have accidentally plugged one in wrong. So always check your numbers after you plug them in to make sure you didn't miss one. So now that I have the list on here, now I'm going to go back to my home screen. So on my home screen, you're going to have to do this next step, which you only have to do if you clear your calculated memory. Go to second 0, which is your catalog, and we're going to scroll down to the D's. And instead of having to scroll all the way down, we're going to hit this button underneath the math button right there, and it scrolls us down to the D's, and then we're going to go all the way down to diagnostic on and hit enter twice. And this turns the correlation coefficient onto your calculator so that you can see what it is. If you don't do that, then you wouldn't see it. So you only have to do that once, or if you clear your calculator memory. So after I plug the data in list 1 and list 2, the next thing I'm going to do is go to Stat, right arrow to calculate. And what am I trying to calculate? Right now we're only doing linear regression. So notice it says for number 4, LINREG. That just means linear regression. So I'm going to hit 4. And then it's going to come up on my screen. So before I hit enter, I also like to put this into my y equals. So how do you put this into your y equals? You have to go to vars, which stands for variables, right arrow over to y vars, because we're putting into our y variable. We're only dealing with functions. We won't do anything with parametric, polar, or the on-off for right now. So enter. And notice that when you do y equals in your calculator, if you look right here in our graph, it shows up as same as it does right here. So these tell us where we're going to put it into our equation. So I'm just going to put it into y1. And notice now, if I hit enter, I get the equation. And notice in my y equals, it came up with the equation here. So what I would do then on my paper is I'm going to write this equation down. So I'm going to go back to my notes. So on my notes, we just did the first part. So first we wanted to decide whether a linear model is reasonable. So if you go back to our calculator, notice that our R value is 0.9655. Usually I round to 4 decimal places when I do my equation and my R value. So the closer to 1 or -1, the better fit the line. So this is very close to 1. Therefore, I would say that a linear model is a good model for this data. Now, I do 0.5 and above is a good correlation. Anything below 0.5 would be a weak correlation, so a linear model would not be a good fit. So I wouldn't then do the equation. So back here, so my R value is equal to 0.9655. And I'm going to write a little note for what this means. The correlation coefficient is very close to 1. Thus, a linear model is a good fit for our data that they gave us. So then question 1 over here says find the trend line, so we're going to write that down as well. So for the trend line, we end up with y equals, and I always like to round to 4 decimal places, so 4.6938x plus 116.5799. And if I go back to my calculator real quick, notice that if this value that's the fourth one right here had been above 5 or 5 or above, I would have rounded the 8 to a 9, and had and for this one right here, since it's above 5, that's why we rounded this 8 to a 9. And same thing, if this 3 had been 5 and above, I would have rounded that 5 to a 6. So keep that in mind when you're doing these equations. So back to our questions, it says, what does the slope tell us? So what is the slope of the line? This is in the equation y equals mx plus b. So this part right here is my slope. So what is this telling us in the context of the problem? So I'm going to write that over to the side here. So for number 2, our slope is equal to 4.6938. And remember that it's rise over run for your slope. So in this case, it's the y values are price in thousands over the year. So I'm going to put in thousands of dollars. So what does that mean? This means that every year the price increases by 4.69 thousands of dollars. Or of course you could just take that 4.69 and multiply it by 1,000 and write out the number. And of course, so you could do that. So then the next part for question number 3, it says, what does the y-intercept tell us? So for question 3, the y-intercept is this part. So our b value is 116.5, and I'm going to round that 799. So you could round that. So for this one, the y-intercept is going to be the starting price in 1990, and of course this is in thousands of dollars. So I would say in 19 so in 1990, the starting price was 116.5799 thousand. Oops. Dollars. So then you ask yourself, well, if we look at our data for 1990, we get 122.9 was the actual data observed value that we got. And we have a y-intercept of 116. So why is there the disparity between the two? You have to remember that we're making the prediction line, and not every single point for this prediction line goes through it, because look at your R value. Our R value is 0.9655. That means that our points are very close to our line, but not exact. So that's why we have a little bit of error for this. And so it doesn't necessarily match what we're given in our table, but that's because we were making a prediction. So for the next question, it says, predict the price in 2010. So if I want to predict the price of this in 2010, then I have to first figure out what is the year for 2010. Because remember, we said let x equals 0 correspond to 1990. So to figure that out, I have to do 2010 minus 1990, and I get 20 out for my x value. So that is what I'm going to plug into my y equals. I'm going to do 4.6938 times 20 plus 116.5799. So when I plug this into my calculator, I get 4.6938 times 20. Notice that I put the 20 in parentheses whenever I plug in variables. I do that. Plus 116.5799. Enter. And I get 210.4559. And of course, remember, this is in thousands of dollars. So if you wanted to, you could multiply this by 1,000, or if you labeled thousands of dollars, that would work as well. So if we go back to our notes, I'm going to write y is equal to 210.4655 thousand dollars. Or if you want to move your decimal place and write 210.4655 dollars like that, that would be okay, because if you go back, remember, we just multiplied that by 1,000 to get that value. Oops. So now we have answered all the questions for the first problem. So before we finish, I want to go back and to our graphing calculator, and I want to look at a couple of things in our graphing calculator. So I'm going to clear the screen. If I go to my y equals, remember that equation we said when we did the y1 from the vars, it puts it in there. So if I go to now zoom, notice if you go down, our calculator has this button that's zoom stat, so we don't have to figure out what the window is. But if I try to use it right now, notice it's going to tell me, I don't think it's going to work. It's just going to draw the line. So in order to use that zoom stat button, you have to go to second y equals, and you need to turn this stat plot on. So how do you do that? You hit enter on the first graph, hit enter on, and then make sure you're in list 1 and 2 always. Even when you're putting stuff into your calculator, list 1 and 2, don't use the other lists for right now. So if it's not in list 1 and 2, you can, if you want to get list 1, you can hit second, and then after hitting second and 1 gives you list 1, and then second 2 gives you list 2. Whoops. So now that my stat plot's turned on, now I can go to zoom, and remember, if we scroll down, we saw at number 9 we had zoom stat, which is cool because it will give us a nice graph. So if I hit that, you can see it graphs my scatter plot with my trend line, because I put my trend line in my y equals already. So those are all the steps that you want to go through. So I'm going to run through them again just so that you can see. So go second mode, puts you to the home screen. So first you would go to stat, enter, and enter into list 1 and list 2. To clear values out, you highlight the list, hit clear, and then down. I'm not going to do it because I'm just running through the steps. Then after that, I'm going to go to stat. I would go right over to calculate, number 4, and then I'm going to go to vars, y vars, enter on function, and enter on y1, and then enter. This puts it into my y equals, and then I would do zoom 9 because that gives me a nice stat plot. So those are the steps that you should be following when you are doing your homework. And if it asks if the model is a reasonable model or not, you would have to look at your correlation coefficient or your R value in order to be able to tell whether or not it's a good model. And so remember, for this one, we said our R value was very close to 1, or if it was very close to -1, that would be what would tell us whether or not it was a good model. So remember, 0.5 and up would be a good, and below that is not going to be a good model.